So, answers to the domain and range. Mark your own. Function or not? Yes, it's a function. Range, Y, funky E-R, all reals. Domain, X, funky E-R, all reals. Second one, function, yes. Range, everything above and touching -3. Domain, all reals. Third one, and I said ignore that little, that's not supposed to be there. That's the photocopier going kind of haywire. Ooh, this one doesn't have arrows on the end. So I got to look at this. The range, it looks like the lowest it gets is -3 and it touches. It's range. And it looks like the highest it gets is +1, 2, 3, 4, 5, 6, and it touches there. I think it's everything between -3 and +6. I think the domain is everything between and touching -3 and +3. I think that's that one. Oh, and it's a function. Here, range, -3, -2, comma, 1, comma, 6. 6, I think so. Range, sorry, domain, -3, comma, -2, comma, -1, comma, 0, comma, 1, comma, 2, comma, 3. This one, not a function. Range, -3, comma, -2, comma, -1, comma, 0, comma, 1, comma, 2, comma, 3. Domain, -3, comma, -2, comma, +1, comma, 6. Range. Oh, function or not? No. Nope. Range, I think all reals. Looks like it goes all the way down, all the way up. Oh, domain. Everything to the right of and touching. Everything to the right of and touching. Bigger than and touching. -3. Ooh, this one comes to a stop. Range, looks like it's every single height between -3 and +3, touching. Oh, and not a function. Domain, it looks like it's every single x value between -3 and +6. Not a function. Range, 0 less than or equal to y less than or equal to 5. 1, 2, 3, yeah, 5. It does look like it goes a little bit higher than 5 right there. I'm going to assume that's kind of a pencil slip or something like that. Otherwise, if you said, I think it went to 5.1, I probably wouldn't argue with you, but I'm pretty sure I'd made this sheet up years ago, and I think I was trying to have it be sort of an ellipse, and this is why I typed my notes, because my artistic skill, as Amber has long since realized, is, yeah. Domain. Between -3 and 3. Function, yes. Range. The lowest we get is -2. We touch. The highest we get is +6, and we touch there too, because the circle is colored in. Domain. The furthest left we get is -6. We touch there. The furthest right we get is 1, 2, 3, 4, 5, 6, 7. Between -6 and +7, touching. And that's a function, if I didn't say so already. Not a function. it looks like the heights that get used up, the range, it's all those heights in that range right there. Looks like, Sam, the lowest I get is -4, touching, range, touching, +5. In terms of my domain, it looks like it's going to be every single x value between here and there. No gaps. Touching, touching. -4 less than or equal to x less than or equal to 4, 5, 7. This one, a function. Range, -5 less than or equal to y less than or equal to, I think that's supposed to hit right there. 4. 1, 2, 3, 4. I think it's supposed to hit there. If you thought 3.5, I wouldn't freak out because that's just bad handwriting on my part. Domain, -6 less than or equal to x less than or equal to everything between -6 and +4. Touching, touching. This one, not a function. I'm going to do domain first. Everything to the right or touching -4. Range, all reals. Ooh. Now, we have to assume that this pattern continues, but Ashley, I think it's reasonable to assume. I mean, it's possible, Ashley, that the graph does that right when it gets off the screen, in which case the range might be all reals. But let's assume the graph continues with this pattern, which means the lowest we seem to be getting is -2. And we touch there. And the highest we seem to be getting is +3. And we touch there. Domain. Are there arrows on the end? I think they're supposed to be. I think it keeps going that way and that way. I think the domain is everything, all reals. Range, -7. Oh, it's not a function, by the way. -7 less than or equal to y, less than or equal to +6. Domain, -6 less than or equal to x, less than or equal to 4. Not a function. Range, it's all reals, but that's because I know this graph, even though it's kind of tough to tell. Let's try that again so it doesn't vanish. Y, funky ER. Domain, I'm going to do this in 2 statements. It's everything below or touching -3, comma. It's everything above or touching +3. But nothing in between. Ooh. Not a function. Range, everything below and touching -4, comma, everything above and touching +3. Domain, all reals, because I think it's going all the way left and all the way right. Not a function. Range, -6, -2, -1, 3, and 5. Domain, -6, -2, 1, 3, and 1, 3, and 7. This funky one, it is a function. Now, Marcus, had they done this and colored that in, it would no longer be a function, because right here, it would fail the vertical line test just in that one location, but that would be the tipping point. The message is, look carefully at hollow circles and dots and things. Range, only 3 heights appear. The height of -5 appears, the height of +2 appears, the height of +6 appears. Yes, I think. Yeah. Domain. Well, this is that one that if I imagine this moving here and this moving here, I actually can get a completely solid with no gaps lines going like that. Because, Garrett, it turns out that gap right there gets filled up by that shaded in circle right there. And this gap right here gets filled up by that shaded in circle right there. I actually just end up with everything bigger than or touching -5. Yes, I think. People nodding. Those are tricky. Oh, I got more? Wow. Okay. Domain. Oh, function or not? Function. Domain. Did I give you this one or not? Yeah, it was attached. All reals, X little funky ER. Range, everything above or touching 2. Mr. Dewick? Yeah, Sam. What if I wanted that same thing but not touching 2? I would have very clearly put a hollow dot right there, and it would have been obvious. You would have seen the arms coming in, but just touching that hollow dot. We'll exaggerate it. Because you wanted to know, right? I could tell. Get your internet going. Domain. All reals, all the way to the left, all the way to the right, forever and ever and ever. Range, everything above or touching -4. By the way, that graph there is the absolute value graph. What letter does it look like? When you're in grade 11, you learn about the absolute value graph, and you have to come up with some dumb way to remember that the absolute value graph looks like a V shape. I've never come up with a good way to remember that the absolute value graph looks like a V shape. You guys have to come up with something on your own. Oh, domain. All reals, range, everything below and touching -3. Domain, all reals. Range, the lowest we get is right there. Everything above and touching -4. Domain. Oh, not a function, this one. Everything to the right, bigger than or touching 3. Range, all reals. Domain, all reals. Range, all reals. Domain, everything to the left or touching 6. Range, all reals. Domain. Range. What kind of a graph is number 8? Linear. True or false? Every linear graph has a domain of all reals and a range of all reals. Convince me.
Because the straight line is continuous in both directions, in both domain and range.
So tell me, is this a straight line?
Yes.
What's its domain? All reals. What's this line's range? Is it every single y value?
No.
So let me ask you again. Is it true that every single line has always a domain of all reals and a range of all reals? Both?
No.
You ready? Every single non-vertical or non-horizontal slanty line has a domain of all reals and a range of all reals. True or false? True. Okay, I think that's what you were thinking. And I think as long as it's got any kind of a slant, eventually it's going to hit negative infinity and positive infinity no matter what. In fact, in Math 11, you'll give an entire group of functions a name. You'll call these odd degree functions. And any odd degree function has a domain and a range of all reals. Oh, for our lines, though, we're going to ignore horizontals and verticals. Oh, verticals aren't even functions, and horizontals are kind of boring. So, just for what it's worth. A little bit more. Oh, no, 8 more. Wow, Mr. Dewick. Domain, all reals. Range, everything below and touching positive 4. 4, 1, 2, 3, 4, yes. Domain, negative 5, less than or equal to x, less than or equal to positive 5. Range, also negative 5, less than or equal to y, less than or equal to 5. This is a graph of a circle of radius 5. Is that right? Someone was looking at me. Is that right? Another circle. Domain, negative 5, less than or equal to x, less than or equal to negative 1. Haven't made a mistake? Someone was looking? No?
Oh, no, I got it mixed up.
I'm good. Oh, range is going to be 1 less than or equal to y, less than or equal to 5. Domain, negative 5 less than or equal to x, less than or equal to 5. Range, negative 3 less than or equal to y, less than or equal to 3. Oh, and by the way, all three of those are not functions. The first one is, though. Domain, 3. Range, all reals. Domain, the first, oh, this is another one where that can cover that can cover that. I can fill in every single hollow dot. It looks like the domain is, furthest left we go is negative 5, less than or equal to x, because we touch, less than or equal to positive 5. The range, only 3 heights appear. Negative 2, comma, positive 1, comma, positive 3, comma. Domain, everything to the left or touching negative 4, that takes care of the left graph, or everything to the right or touching positive 4. Everything bigger than or touching positive 4, or everything smaller than or touching negative 4. The range is all reals, I'm pretty sure. Domain, all reals. Range, negative 2, less than or equal to y, less than or equal to 2. So there is a really, really quick answer key. Any of those that you were going, oh, how the heck did you get that? Now is your chance to ask. Yes? The second one. Second page, second. Show me the picture, please. First page, back of the first page? Oh, the very last page? Okay, which one, sorry? This one here? This one? Yep. Am I wrong? I might be. What was your question, kiddo? So the fact that that dot, this line, can slide up bump, and color in that dot, and I can treat them as one single solitary line, and I can do the same here using my imagination. Really, in terms of the left-right, that's just like a line from here to here. That's how I was able to say it's everything between negative 5 and 5. At first I thought there was a gap there, but then I went, oh, they colored that gap in down there. I thought there was a gap there. Oh, no, they colored that gap in right there. Okay? Heights. Which heights appear? That height, that height, that height. I didn't really move the lines up and down. I just imagined that I could to get the domain, but to get the heights, I leave the lines as is. Is that all right? I hope. Any others? So if you have that done, hand it in. Some of you were copying. Lesson 6. Representing functions and relations. Some of this is going to be kind of dotting the I's and crossing the T's and sort of, Brianna, reviewing in more detail, but formally, and some of this will be new. So far, we've talked about the idea of a function and a relation without actually defining the two terms. A function or a relation is just anything that connects one set of numbers to another. That's the mathematical definition of a function or a relation. You could actually give it as an English rule and be even more generic, but for math, if it's some kind of rule or procedure that connects one group of numbers We call that the input, the domain, the independent variable, and turns them into another set of numbers. We call it the output, the range, the dependent variable. We call that a relation. Oh, and if that relation also passes the vertical line test, we call it a function. Anthony, all functions are relations. Functions are a special subgroup of relations. So not all relations are functions, but all functions are relations. Anything that's got a rule is a relation. Oh, passes the vertical line test, it's also a function. So the numbers going into the function or relation are called the input. These are the domain. Numbers coming out of the function or relation are called these are the range. Here is the difference between a function and a relation by looking at the two diagrams below. Look at the relation. You'll notice that for that single input, there is more than one possible output. That makes it a relation. One is still okay, but if you have more than one, it's not a function. Really, here's what we say. If it's a rule, it's a relation and a function. If that rule, Garrett, only gives you one output for every input, that's a function. A relation has, now, all functions are relations, but a relation can have more than one output. For each input. You might have more than one. There are many, 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 many different ways of representing functions and relations. Each of them have their advantages and disadvantages. Our preferred method in math is almost always going to be the equation or the graph. But let's look at the equation y equals x plus 2. You can represent it as a table of values. Say what? You could go like this. Draw a little line down the middle. Yoink. Call this x. Call this y. Yoink. 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 And you could try putting in some inputs. What would be nice numbers to try? I always actually, Darian, start out with an even better number than that, 0. Because if it's 0 for x, that also means it's a y-intercept, which that's easy to graph because I almost always have a y-axis. Put a 0 in for x. Put a 0 right there. What does the right-hand side work out to? What is 0 plus 2?
2.
So you're saying y must be 2? Yes. Then my next one I try is 1. Help me out. 3. And then actually, Darian, the next one I try -1, 0, and 1. Because I figure I've just gone to the right of 0. Let's go to the left of 0 and see if this pattern continues. And 1, yes? Could you try 10? Yeah. Marcus, could you try 17? Sure. Could you try -37? Sure. I usually stick close to the origin because almost always if it's graph paper, I have a limited amount of graph paper. Rarely do I have a piece of graph paper that has 41 squares on it or 62 squares on it. As a list of ordered pairs, 0, 2, 1, 3, -1, 1, 198, 200, yes. Ashley looked at me kind of funny. I mean, that's on the graph. That is a legitimate point. Would I use it? No, but I want to remind you, it's there. Brianna looks at me. I can one-up you. How about 1 million, comma, 1 million and 2? Yeah, okay, shut up. But yeah, whatever. Oh, and you can go -2. Oh, and you could use decimals if you want to. They didn't say I couldn't use decimals. How about 3.8, comma, 5.8? Sure. Keep it simple. Generally, I go -1, 0, 1, -2, +2, -3, +3. If I haven't figured it out by then, I'll go -4. I'll slowly keep moving 1 out. But if I haven't figured it out by the time I get to 10, probably in math 10, I'm doing something wonky. I've made a math mistake. How would you give that rule in words? How about, can you give me the rule using words like input and output? Specifically using the word input, because +2 doesn't, that's just a dangling modifier. Like that? Sure. How about add 2 to the input? By the way, I'd probably take +2, but let's be a little formal in our notes. We could do it as a graph. This graph goes through, let's call this 4 and -4. Here's how we're going to freehand sketch, because they didn't give me graph paper. Amber, what would that be then? You think that'd be 3? Why 2 and not 3? Didn't I divide the 4 in half? Yeah, that's what I'm trying, right? I'm going to call this 2. Amber, redeem yourself. What would that be then? There. Okay. By the way, Amber, look up, look up. What would that be? Halfway between 2 and 4. There's where 3 would be. There's what, I'm not going to label those. It's going to be crowded. This is how, if you're trying to freehand and you want to make fake graph paper but be fairly accurate, pick a nice number for the outside and then start dividing in halves, because Amy, all of you can eyeball a half pretty good. But if I said eyeball it into thirds, that's much tougher. Or eyeball it into sevenths, ain't happening. I'm going to do the same thing here. 4, -4. That's going to be a -2, a 2, 3, 1, 1, 3. From my little table of values, what are some points on this graph? What was the first point?
0, 2.
Ta-da! What was the next point? 1 over 3 up. Ta-da! What was the next point?
-1, -1, and 1.
Ta-da! Are they forming a line? Did I know that ahead of time because there was no funky exponents and stuff? Yeah. So I think it also goes through there, and that's good enough because I'm freehanding. Ooh, that's terrible. No, you know what? I'm freehanding. Did they give me graph paper? Then they can jump in a lake if they want better than that. If they wanted me to get better than that, they would give me graph paper. If you have lined paper, that's sometimes a bit easier because you've got kind of a horizontal graph at least. You don't have vertical lines. You got, anyways, freehanding. Mapping diagram. -1, 0, 1, 198. -1 went with what? 1. 0 went with 2. 1 went with 3. 198 went with 200. And we would show that these mapped like that. Equation. And that is a function. I think the equation gives me the best bang for my buck. In terms of Garrett, it's short to write. The equation lets me generate the table of values if I need it, yes. It lets me come up with the points if I need it, yes. I can turn it into words if I need it, yes. If you give me graph paper, once I've done a table of values, I can generate it as a graph. I think in terms of bang for my buck, everything's contained in the equation the best. But I'm biased. Turn the page. Okay. It says, fill in the missing representations of the following relation or function. So, starting out with a table of values, not my favorite one to start out with, although I can get the ordered pairs pretty easily. I guess this is going to go through -2, 6, -1, 3, 0, 0, 1, -3, 2, negative. Okay, that wasn't too tough. Who sees the rule? And this is a tough one. I've upped the ante. Can you figure out how to turn a -2 into a 6, a -1 into a 3 using the same mathematical group of steps, a 0 into a 0, a 1 into a -3, 2 into a 6? Yeah.
Multiply the input by -3.
Really? Is that it? -2 times -3 is +6. -1 times -3 is +3. 0 times -3 is 0. That works. 1 times -3 is... Oh, heck, I'll just write it. I can't get my cursor to click there. Multiply input by... What'd you say, Ben?
-3.
I agree. Which gives me the equation right away. Y equals -3x. Yes? Graph. Could we graph those points and connect them? I'm going to skip that. Mapping diagram, could we list them and connect them? I'm going to skip that. Can you, by looking at this, tell whether it's a relation or a function? By the way, I shouldn't say relation or a function. It is a relation. Everything's a relation. But is it a function or not? I'll need to retype this next year and fix that. I wasn't thinking when I did this. Okay, for each of the following, it says complete the pattern. State whether it represents a relation or a function. So here's a mapping diagram. Apparently a 3 became a 12, a 1 became a 4, a 0 became a 0. What would a -2 turn into? Convince me. So you're saying the rule is that? Yeah? So -8? Oh, what if I ended up with a -4 as an output? What was my input? I agree. Is that a function? Well, the nice thing is, because it's an equation, I'm going to tell you, because it's a linear equation, all lines are functions except one, a vertical line. And a vertical line, you'll learn in a little while how to spot it. This is not a vertical line. This is a function. B. Forgot to write here, function. B. Jordan. What's an easier way to write times by itself? Ooh, are you saying the equation is this? It is. How'd you spot that? Here's what I'm going to guess, though. You stared at it, you started trying stuff, and all of a sudden your brain got your brain's got itself's attention and said, hey, I see it. I don't know how to teach this part. Garrett, this idea of here's a pattern, spot it. Our brains just do it, and you practice and you get better at it. I don't know how to teach that part. Sorry, I've never figured it out. So I agree. So blank here would be what? 9, yes? And if I got 16, what's my input?
4.
If I got 16, what's another possible input? Right? Function or not? You know, you're saying, ooh, Mr. Dewick, the number 9 appeared twice. Here's what you're looking for. Does any x value appear twice with a different y value? Oh, learn to write, Mr. Dewick. I put the fun in function. C, function or not? Not. It says complete the pattern. There's really no pattern to complete. It's a circle. Mr. Dewick? Yes. What would the equation of that circle be? What's the radius of that circle?
2.
Trust me. 2 squared, by the way. If it was radius 3, you know what number would be there? 9. If it was radius 5, you know what number would be there? 25. And then it's going to look like this. You don't need to know this, Semi. I'm just doing it because I'm a nerd, but you can write it down if you want to. That's the equation.
How'd you get that, Mr. Dick?
Where's the center of this circle? What comma what? A circle that has a -2 comma +2, you'll learn in Math 12 that everything's backwards. To move x2 left, you actually put a positive there, and to move y2 up, you actually put a minus there. Normally that circle would be centered at 0, 0, 2 left, 1 up, 2 up, and then there's your radius. Math 12. Preview of coming attractions. I'll erase this so as not to scare you. Let's do the next one. For a bike-a-thon, Natalie has pledges totaling $1.40 per kilometer. The maximum distance she can cycle is 100 kilometers. Fill in the table of values relating the distance in kilometers that Natalie cycles, D, and the amount of money, A, she collects. So if she cycles 10 kilometers, she gets $14. If she cycles 20 kilometers,
28.
what if she cycles 30 kilometers?
42.
What if she cycles 40 kilometers?
56.
I heard 54 and I heard 56. Which one? 56? Yeah, I think $56. What if she cycles 50 kilometers?
70.
How are we getting this? I'm not adding. I'm doing something even easier. Got your calculator? What is $1.40 times 70? What is 1.4 times 70? What is 1.4 times... Sorry, what is 1.4 times 50? 1.4 times 50? 70. I'm multiplying by 1.4. I'm actually multiplying by 14 and then just lopping off a 0. I'm better at timesing than I am at adding. You guys are just adding, what, 28 or $14 each time? That works as well. So you're saying this is going to be... Yeah? Well, fill in the rest. I'll do it up here. Let's see if we get the same thing. Yes? B says, write the equation relating the amount collected and the distance cycled. First of all, does how much money you get depend on how far you bike? Or does how far you bike depend on how much money you get? Which of these is the dependent variable? The money. You know what the independent one is? So I'm going to put that one where the x is on the x-axis. I'm going to put money on the y-axis. But I don't want to use x and y. What would be a good letter to use for distance? What would be a good letter to use for amount? Can you give me an equation? A equals what? If you know the distance, how can you calculate the money? So I don't want to write times 1.4. Can you give me an equation? A equals what? Oh, thank you. He's going to say D 1.4. Wait a minute. I've done enough math to know that we usually put the number in front of the variable. Thank you. I think here's my equation. Yeah? Little trickier to spot than squared or times by 3 or whatever. Use your table to graph. Okay. We're going to graph amount and distance. The amount is in dollars. Distance is in kilometers. Now we're going to have to adjust the scale. How many squares long is the bottom? Count, please, carefully. 14. Is it 14 squares long? How far does this person cycle? Longest distance. So what would make sense as a good scale for each square to be worth so that I use up most of the graph? If I got 14 squares and I'm cycling 120, what would be a good, each square be worth what? Why 10? Oh, that uses up 120 out of 114. That's 12 squares? A dumb scale would be going up by 5s. A really dumb scale would be going up by 1s. Because then you need 120 squares, and how many squares do I have? 14. So pick an intelligent scale, one that uses as much graph paper as possible. So each square is going to be 10. So this first hash mark here is going to be, you know what, I'll change colors to make it stand out a little bit, Mr. Dewick. 20, 40, 60, 80, 100, 120, 140? Is that okay, Brianna? Make sense? How many squares do we have vertically? Is it also 14? Double check. I don't think so.
15?
Is it 15? How much money does she earn? Grand total maximum. 468. I got 15 squares. I want to somehow fit 468.
100.
Oh, what? 168. Oh, that's 400. Like, seems a little high. I'm not paying her that much. 168. It'd be nice if it was closer to 150, because if it was 150, I'd do the same thing. I'd let each square be worth 10. You know what? I think I'm going to let each square be worth 10, and we're going to have one point that's going to be an outlier. It's going to be hanging in midair a little bit, and I'm going to say, live with it. So I'm going to do the same thing. I'm going to say, let's go 20, 40, 60, 80, 100, 120, 140. What's the first point on this graph? What, comma, what?
10, wait, never mind.
You were right.
10, 14.
So I can do the 10 bang on. 10 is right here. Now the 14 I'm going to have to eyeball. The 14 is going to be just below halfway to the 20. Yeah? Like right about here? I think. What's the next one?
28.
Sorry?
20 and 28.
20. Thunk. 28. Just below the 30 high. About there-ish, give or take. What's the next one?
30, comma 42.
30, comma 42. Can I fit this all? Not quite. Let's go to 150 size. That'll fit. 30. 42, a little bit above 40. About there. Next. $40, comma what?
56.
A little more than halfway to the 60. Next. 50, comma. Dead even? Hey, good. I got one nice point there. Whew. 60, comma.
85.
Not quite halfway to the 90. 70, comma.
98.
Just below the 100. 80.
112.
Just above 110. 90.
126.
Just about a little more than halfway to 130. Between 120 and 130. Next one. 100.
140.
Woohoo! I can do that one bang on. 110.
154.
I think we're going to have kind of a point there and kind of a point kind of there. Okay. Live with it. By the way, is 0, 0 on this graph? Curtis, is he alive? Oh, he is. Okay. 0, 0 on this graph? If you cycle 0, will you get any money?
No.
So I would make an argument that this graph does go through zeros. But not all graphs do. So there, we've done part C, graphed. D, should they be connected? And then I wrote explain. Convince me. Yes or no, should they be connected? Is this graph a discrete or a continuous graph? Discrete means unconnected, is that what you're saying? Convince me. But that just tells me the domain. It means the graph is going to come to a stop. In fact, the domain will be between 0 and 120.
Because she can't earn like 12 or like 16. It has to be like 14, 28.
Okay, I think Sam's on the right track. Sam said she can't earn like 12 or 16. I think because it's $1.40 per kilometer, she can earn 7 kilometers because I can go 7 times $1.40. But what if she cycles 7.2 kilometers? What am I going to pay her? I'm paying her 7 kilometers, right? I've done fundraisers. What if she cycles 8.7 kilometers? I'm sorry, she's getting money for 8 kilometers. That's how fundraisers work. So I think this should not be connected. I think there should be more points. I think there should be 1 dot for every kilometer, but I think it is discrete, I would argue. What's your homework? Number 1. Number 2. Three. 4 is good. Are you going to sign everything, Mr. Dewick? Maybe. Yeah, 5 is good. Yeah, sure, 6 is good. And yeah, 7 is good. Back. But you don't have to do the answers. Oh, well, you can check them, though. Okay. You got almost a half hour. You got lots of time. You'll get it done in class.